Hi, everyone. Hope you're having fun while learning new things. Guess that one is one of the few downsides of this conference being fully virtual because I can't hear if you're giving me dead silence or verbally agreeing. So let's just assume that what I said is true. So it's going to be quite impossible for me to top Ian as your host, but let's see what I can do. It is time I introduce to you our next speaker and his talk. Fadil Mohammed El Ehdad will show us what to do to monitor and improve your Shiny app's performance. Fadil is an R-Shiny developer, a holder of PhD in economics, and also an author and maintainer of an impressive number of R packages. And besides R and Shiny, he's interested in implementing machine learning algorithms to solve complex real-world issues. Now, this is probably quite a cold take given the audience we have here, but I think measuring your app's performance is crucial to make sure those apps are successful, and hope we can all agree that fantastic user experience and adoption are most important. As Philip noted, nobody wants to use ugly and slow apps before. And I'm sure Mohammed's experience and techniques that he uses to develop smooth and efficient Shiny applications will be very valuable. Just a friendly reminder, please ask any questions you might have for our speaker in the chat. And off to you, Fadil. The stage is yours. Thank you.
Thank you, Andre. So I will just share my screen. And just a second, I will share my entire screen now. I hope you can see my screen now.
Yes, we can.
Perfect. So I will just open the slides. Great. So thank you so much, Andre, again. As mentioned, my full name is Mohammed Al-Fadil Iadadan, but everyone calls me Fadil. At the moment, I'm an R and Shiny developer at a company called SSV Trading, based in Hamburg, in Germany. Originally, I'm from Algeria, but I'm living in Germany since almost 2 years now, and yeah, we do a lot of R and Shiny in production, so it's quite cool. And I mean, in this context, we did a lot with performance, speed, and Shiny efficiency, because like the faster your app is, the better. Of course, in a production environment. And so I will try to explain what I personally consider really important in the context of Shiny performance. How can I monitor my app's performance, and how can I improve it? So when we talk about like R performance or Shiny performance in general, we might think, okay, we can use like the print function and calculate the time of execution of a function, or maybe use the TikTok package or any package that can calculate the time of execution of a script, of a module, of any part of a server, which is not a bad idea, actually. It can be a good idea, because Shiny is R, right? It's R and many other languages, but part of it is mainly R. We can use also the profiling tools. Many profiling tools are available already. I can mention the profiling tool in RStudio, which allows you to really find where any part of any function is particularly slow or not, and it's quite interesting. But today I want to talk about like the web development aspect of performance, and I wanted to talk about the core web vitals. So in the web development world, Google, which has really tremendous power in terms of ranking like websites and web application, has, many websites, to be honest, has developed or introduced some metrics. And these metrics allows one to measure in really precise way an app's performance through some values. So what are these core web vitals? So they are values, as said. They are metrics that are used to quantify performance. But what's cool is that they're real user. They are based, sorry, on real user interactions. So it's not only like dummy metrics, but it's really based on what your user, how your user interact with the app. So there are many metrics, but I will just mention the most important, the one that Google use in order to rank most websites. So there is firstly what's called the first contentful paint, or FCP. It's simply put, it's the time between when your app starts loading and to the time where you see something, a content in your app, anything, right? So I start my app at second zero, sorry, and then I see something. This is the time where I can, say that I have a first contentful paint of something, of a value. So the first time where a content of the app is rendered. Here, for example, just imagine that this gray here box is a Shiny app. It's loading. There is a time execution here, and it goes until I see, for example, a logo of a Shiny Hex sticker or something in the top right of my app. So this is the first contentful paint. Then there is what we call, and it's really important, and this matrix is, I think, more important than the previous one. It's called the largest contentful paint. And this is the time between when the app starts loading and when an important, or a large content in your app is rendered. By a large content, it can be an image, it can be a div, or any element that will be considered when measuring this large contentful paint value. Here in this example, let's say we have a Shiny app and we have a plot, like a large plot, which will be displayed when the app starts or at any point. And when the plot is showcased, this is where the large contentful paint will be measured. So you can see here a large content is rendered. Okay? This is the largest contentful paint. And then we have what we call the first input delay. And it's also important because the first input delay measures it or calculates the time between the starting of your app and the time where the user can actually interact with the app. So let's say we have a save button that will allow me to save my image, but at what time will I be able to save the image? Maybe I have like a big script in the background that needs to run or to be run before I can click on the save button, and so on. So this is really like an important metric. Finally, there's a fourth metric, which is called the cumulative layout shift. And this metric will be calculated actually several times throughout the time of execution of the app. So let's say I have, for example, a gray app here. It's loading, I have nothing. Then some time passes, I don't have anything here. I have only a save button and my logo. And so another amount of time passes. And let's suppose that I have like a script that calculates something and it takes a little bit of time to render the plot. So then at time 2, after a considered amount of time, the plot is rendered. But the issue here is that the save button will be shifted to the bottom. And this is really annoying to many users, especially if the app or the website is slow, because a user doesn't like when things move unexpectedly, right? When it's expected, it's really good. So when it's expected, when I click something, I should, see something moving, it is fine. But when it's unexpected, like here, for example, something is calculated and then I see a plot and then something shifts, it's really bad. And like Google has provided this CLS, or cumulative layout shift measure, in order to quantify this phenomenon. And it can be anything. It can be a shift of a plot, a shift of a button, a shift of like a menu, a shift of a table, and so on. Good. So how to calculate these core web vitals? Actually, it's super easy. So there is like a first tool, which is what we call the Lighthouse extensions within like the dev tools. So if I go to Chrome, but I think it's also available in Firefox and other web browser as an extension. So I will go to here to test app. Let me just open this app. Can you see my RStudio at the moment?
Yes, we can.
Perfect, thank you so much. So I just created the Shiny app, like a really normal one. When you create like file, new Shiny app, you get this template from RStudio with some comments. I can remove them. So if I run the app, you know, I can just see here the histogram at the right and some inputs on the left. So if I want, I mean, it doesn't really make sense to calculate the performance of the app because I know it's super performant. There's nothing inside. But just for the sake of the example, so this approach works with large apps too. So I can just go on the inspect, and here, make sure that your DevTools is not like is really out of your web page, of your browser. I mean, if it is like this, for example, if it takes, for example, a space or an amount of space in your page, it will like make your calculation not that reliable, because the Lighthouse should calculate the performance of your app according to a normal screen. But if you do it this way, if I go, for example, here to Lighthouse and go analyze page load, it will, take into account this amount of space, which is actually not right, because most people actually in most companies use a normal screen, right? So this is what I will do. I will just open my DevTools in a separate tab. So I will just go this way in doc, and then I have my Lighthouse extension here, and I will just choose here, make sure to choose performance. You can, of course, choose accessibility, best practices, SEO, and so on. But in this case, we are talking about performance, so let's pick this. And here, make sure you are picking desktop. You can also use mobile, but let's focus on that. I will focus on desktop in this talk, on desktop apps. So I just click Analyze Page Load. It will take a few seconds. The page will reload. And at the end, I will get a report back with some information. So here you can see I have a score, a really good one. Actually, with the real app, I won't have this score, but it's fine if you have like a score between 50 and 70, you're really good. And it gives me also here some information. So it gives me, like, for example, the first contentful paint. It gives me the largest contentful paint. It gives me the cumulative layout shaft, which has a value of 0, which is really good, because I mean I don't have nothing shifted in my app. But I have like my first contentful paint, my largest contentful paint. It's not that bad actually, because Shiny loads some JavaScript files at the start, but it's not really bad. So you can see here how easy you can at first see how your app is doing in terms of performance, right? In terms of Web Vitals performance. So it's just a matter of clicking Lighthouse and then generate report. The issue here is that we are calculating or monitoring performance according to what we call laboratory data. And this is not really robust, because I mean the performance of your app within your laptop will differ from the performance of the app within, for example, a server, which is deployed in a server using, I don't know, RStudio Connect, Shiny Proxy, or anything on another computer with another amount of CPU, of RAM, etc., etc. So, like, measuring apps performance this way is a good step, but it's not that robust. And furthermore, you're not like, you just like calculate the performance at a specific amount of time, but you have no traceability, right? You will have to do it like every, I don't know, time, and you have to note stuff. Maybe it's not that robust. So there is a better way to do it. And the better way to do it is, I'll just close this, is actually to use field data. So field data are actually like data collected from the users. So I have an app which is deployed somewhere. I put like the tool that I will talk about, I implement them, and then whenever the user connect or interact with the app, I will collect live my Web Vitals values, and I will store them somewhere. So Google Chrome has developed this repo, this really cool repo called Web Vitals. So it's on Chrome, it's on GitHub. It's a JavaScript library that provides the values or the metrics that we have seen so far. It's really simple, but it's really effective. And it's extensively used by the community. Unfortunately, there is no, to my knowledge, of course, there is no equivalent in R. So I have created the package, a small one, that wrapped this JavaScript library. It's not yet on CRAN, but it's hosted in GitHub. And the package allows you to do the same. It's super simple to use. So it provides like 3 metrics, because the Web Vitals JavaScript library also focuses on 3 metrics. So it focuses on the first input delay, the largest contentful paint, and the cumulative layout shift. And so I will just give you an example so you can read the docu. It's super simple. There's only one function actually, which calls Web Vitals implement Web Vitals. And I will give you an example. So I will go to my RStudio. I have this really simple app here. If I run it, super simple. So there is a title, amazing title. I have a plot output. I have a button. I have a table output. That's it. And I use this function from Web Vitals called implement Web Vitals. And it takes 3 parameters. So the first parameter is called the FID ID. And here you will give a character string of the ID that will be used later in the server, or the ID of the reactive values that will be used later in the server to collect the information. I will explain it. It's really easy, and you will see that you will see it later. But for now, just focus on the parameters. I have like also an LCP ID, and I have a CLS ID, so I can give anything, whatever I want here. And then I have a parameter called wait to get info, because the issue here is like the user, when the user interacts with the app, some parameters will be like some web metrics will be available really quickly. For example, the first input delay, but the cumulative shift layout or the cumulative layout shift, for example, won't be like available immediately. The user will have to click. The user will have to interact with the app in order to get the metric. So that's why I have implemented this wait to get info. It's like you put like a value here in milliseconds. You say, for example, I want to wait 10 seconds in order to get the values. And the more you wait, the more you're sure to get the values. And then you will get the values. Also, it's just like whenever you see here a waiting, it can be dangerous. But here, it's just like in the JavaScript side, I have put a set timer which won't block your thread of execution in your browser. So it's super safe. So you can just use here a time, and JavaScript will just queue the function in the JavaScript side. And whenever the time is elapsed, it will collect the info if available. If not, you will get nothing. But if you set this value to a good amount, you will get the information. So this is how I use like these implement Web Vitals. And in the server, it's quite particular, but what I need to do is simply an observe event. So you can see above, I have provided my IDs. So in order to get the values, I will just have to observe this here, input $ID, and then I get the values back. So what it means, I will just put a browser here. I will do a restart. And then I will just run my app. And I will wait a little bit. Maybe I will interact with the app. The app is super small, so it's quite hard to get the values. But here you will see in the browser, the app stopped because this 10 seconds were elapsed, and this value here, this my first input delay, has been collected or could be collected. So what I can do here is simply print the value in my console, and you can see that it's a list, right? Because by default, in the JavaScript side, it's a JavaScript, it's a JSON object, but by default, Shiny converted to a list object, and it gives many informations or many useful information. It gives like the name of the metric, which is like first input delay. It gives a value. It gives a rating, a delta, which is like the changing between like the value of the previous values, and other metric like start time, duration, processing start, and so on. Concealable true, and then ID. And here in the server side, I didn't want to implement anything within the package. I wanted to give to the user or the developers of Shiny apps the freedom to do whatever they want with this information. So here, you might think like you can just put this observer within your app in production, and then just like convert this list file or take whatever value you want and write it in a CSV file, write it in the database, in a table, and they're just, collected through time. And then you can always plot it, like create a dashboard that will just show the evolution of your performance, of your first input delay, of your LCP, and or CLS, and so on. So this information can be collected, and it's up to the user to like save it as she or he wants. Okay, so this is what I did. It's pretty easy. Do I have still time, or should I like rush a little bit?
Well, we started a little late, so I think you should have 5 to 10 minutes.
Okay, cool. Okay, cool. So this is what the app does here. So I can just it's just a matter of observe event and then do whatever you want with your the input that you get. Yes. So now, what I want to talk about is like how to improve the app's performance, right? Because monitoring, it's quite easy, but how to improve it. So I will talk about my experience in the production field. So what I have seen in most apps, so I have like talked to many people, and many people like say, oh, my app is slow, there is some Shiny is slow. And I want to say that Shiny is not slow. Shiny is as slow as your R code. So if your R code is slow, your app will be slow. That's for sure. But if your R code is fast, your app will be fast. So what I have seen is like most people, for example, I give you like a really concrete example. Most people will use like a big CSV file, and people will simply use like the base R read.csv, which is like super slow, and then we'll say that Shiny is slow. Just like an example of how to like improve by I don't know like a ratio of like by 10 times like the performance of the app. If I use the fread function from data table instead of read.csv, I will improve the efficiency of my app by minimum like 10 times. So this is just an example of just like by looking at your code, at the function that are used in your app, you can really and dramatically improve your app's performance. And this is where one need to start. Then there is really also an important observation. I think that we should only load the data that we need. So I have seen many apps, and most apps really like load all the data at the start, and then process the data and filter and so on, and provide like these plots and dashboards, maybe processes, etc. So instead of putting a read.csv or an SQL query at the beginning, at the starting of the app, the best way is to simply like provide a load button. So whenever the user is ready to load the data, then she or he will click on the load button, but never at the start of the app. So only load the data that you need and when needed. Okay. So there is also the concept of optimizing the backend code. So if I just give an example. So here, for example, let's say I have a query, an SQL query that select a table from a database. So I have a select star from this table where, for let's say, where a date is today. So the table has a column date, and I select all the information where the date will be equivalent to today. So in the backend, in the database side, in the SQL side, just for example, by creating an index, I will make my query at least 2 or 3 times faster, especially if the table is important. So this is also like really something that we tend to neglect, but it's really important. So optimize your backend code if possible. And then, of course, I have talked about it, but load data only when needed. And then it's a bit controversial because there are many packages in order to showcase or display tables in Shiny. But I think, according to my experience, that the DT package is the faster and is the most efficient when you're dealing with a large table. When I say large table in Shiny, I mean you're showcasing something more than 100,000 rows, with more than 100,000 rows. And I think the DT package does a really amazing job in this context. But there is a trick. Never, ever do server equal false. Always use server equal true, because if you do server equal false and some app use it, and your table is quite large, so all the information in the table will be like available in the client side, which will make the app really, really slow. So the only purpose of doing server equal false will be to just like have the data available in the client side and then maybe download it easily. But even in this context, it's not interesting, because you can always create in Shiny a download handler, a download button, like in the server part, which will handle the download part. So I don't know why one would use server equal false. To be honest, maybe in the comments or in the questions, I will have more information. But according to me, always use server equal true, then it will be super fast. And I want to talk also about like using a JavaScript like libraries. So most JavaScript or more packages that will be used, that are used in Shiny, generally wrap a JavaScript library. So DT, for example, wraps the data table JavaScript library. HighCharter wraps many JavaScript files, and so on and so on. So many packages rely on JavaScript libraries. So for example, if I have to provide like an interactive plot in my app, I will tend to avoid using many interactive data visualization packages. So if I have an app and someone tells me I need like an interactive plot, I won't use, for example, HighCharter and Plotly, because both rely on JavaScript library and both will load a large amount of JavaScript files at the beginning of the app. So I will tend to pick one, the one that suits my need, maybe HighCharter, maybe Plotly, maybe another package, and then use it and focus on it. So the more JavaScript files you're relying on in your app, the slower your app will be at the start. Okay? And then, concerning the cumulative layout shift, there is a really easy trick in order to minimize it or to optimize the score of your cumulative layout shift is simply whenever you have like a table that won't be rendered immediately, or a plot, by simply using the max width CSS property within the div of your plot of your table, this will make your content fix. And this will, won't allow your div to move and to shift. And this is super easy to do and really effective. So I highly recommend it. And of course, there are many other tips, and tricks to improve your app's performance, but I unfortunately don't have time to go into details. So thank you. And if you have any questions, feel free to ask.
Thank you so much, Fadil. That was great. So yeah, there are a couple of questions, but I just wanted to say that I enjoyed looking at the chat through your conversation, through your talk, because I had a question marked that, it might be intimidating for new people to learn those techniques, and what would you recommend for them to get started? However, we can see a lot of, seasoned wolves in the chat saying that they've been quite, they haven't seen what you showed them yet, or they're new to this package, or they've got a lot of work to do on their app. So I think this question is not exclusive to new people or starters. So yeah, is there any resources or any particular place you could recommend to start with? Because maybe there's a lot of other things that people can look for.
So do you are we talking about performance or Shiny in general?
No, performance and measuring the performance and improving it.
So the performance, I will say, because Shiny relies tremendously on R, at least Shiny R, because now that is like the Shiny in Python. I think one needs to start in R. So one needs to be really good at R. So I gave the example about the read.csv, but if you have a little bit of experience, you know that fread from data table is 100 times faster, and that should be used in your Shiny app. So this is really a small example about like improving your performance of your code. So you need to know how to improve the performance of your R code before improving the performance of your Shiny app.
Got it. I think that was summarized pretty well in the chat. Your code sucks, therefore your app is slow.
Yeah,
is that
exactly.
correct?
Yeah.
Okay.
Exactly.
Fair. So so we're running quite late, so I'll ask one more question if that's fine. So Jeff Craggy asks, what are the benefits of these metrics as compared to, let's say, Shiny React Log?
Shiny React Log, I didn't use Shiny React Log, to be honest, but let me just Google it quickly. Shiny React Log. I don't know what Shiny React Log provides. I think it's something, okay, I have used it before, but Shiny React Log is something completely different. It doesn't provide metrics for performance, but it kind of provides like a really nice visualization about your app's reactivity, so that you can track the reactivity of your app. So you have many inputs and you have many outputs, and in Shiny it can be messy with time because your app will get really, like, you get bigger and bigger, and it can be hard to track. But Shiny React Log will allow you to have like an understanding of this reactivity, but it's something completely different. It doesn't have anything to do with performance.
All right. Thank you so much. So conscious of time, we'll move on. I just wanted to encourage everyone to ask questions either in this chat or in the ShinyCon Slack. I have a feeling, Phil, that you'll have a lot of questions after this presentation, so brace yourself.
Sure. Thank you so
again.
much, Andrzej. Thank you.